What's up, guys? Welcome to episode 2 of the Crypto Poppy. Today, I'm really excited to talk about oracles. So, I think this will benefit not only the investor, but as well as the developer that is interested in developing smart contracts. So, I prepared a little presentation. I think this is going to be a short episode, and you have to do your due diligence after and do your own research. If you're more interested, I'll set up a bunch of links down there. So what are oracles and why did I want to make a whole episode about this? So first of all, you kind of have to have a certain basic layer of knowledge about Ethereum. So Ethereum is a programmable blockchain. It's a fork of Bitcoin. But the difference between Ethereum and Bitcoin, as you may know, is that, as you can see here, Ethereum allows users to create their own operations of any complexity they wish. And so you have to see it as a way that Ethereum is actually a platform for many different types of decentralized blockchain applications, or we call them dApps. But it's not limited to cryptocurrencies. And the way that it runs is that each computer that downloads the Ethereum node can run as a phone node on the platform, and it connects all the computers. And for this reason, sometimes Ethereum is actually described as a world computer. So once there's a transaction done between any smart contracts that use Ethereum, then that transaction has to be confirmed, and all the computers agree that that is actually what happened. So you have to know that, and that's very important for the rest of the talk. Now, the thing is, smart contracts are actually code, right? So this is the difference between coins and tokens. Coins are platforms. So you have Ethereum, you have Litecoin, Bitcoin, Monero. These are all platform. The difference with coins and tokens is that tokens are what you buy or purchase, so on these exchanges like Binance, in order to be able to use that platform. Whatever the platform offers, whatever the assets are, the tokens are kind of like what you use. So like think about Chuck E. Cheese. Like you go in Chuck E. Cheese, there's a bunch of games, there's a bunch of stuff to do. But before you can play the games, you got to buy a bunch of tokens, right? So I guess people, when they're buy tokens on an exchange, they're speculating that the token will go up in value because there will be more and more users on that network. So what's interesting about oracles, and that is the premise of this episode, is that in the smart contract there's only code. So you cannot see anything but the logic, like the business logic behind the token. How is the token going to work? And sometimes in these smart contracts you have to extract data from the outside world, because these contracts have to be validated that an event occurred. So you got to think about it like, okay, let's say there's an insurance contract that says that if your flight is delayed, then you will be paid a certain amount of money depending on how many minutes the flight is delayed, right? So you're going to have to the smart contract is going to have to get out of its scope in order to get that data from, an API or a different source that is responsible to say, like a website says, this flight is delayed by 5 minutes, and then the smart contract is listening to that, and then when it gets that data, there's a callback, what we call a callback method, and then all of a sudden it's executed, and boom, you have a certain amount of tokens in your wallet. So you can kind of see it here in this slide with the allusion to the Matrix, one of my favorite movies for sure. So here you validate that the conditions within the smart contracts are met, so the oracle is telling Neo what exactly happened, and then this triggers an actions accordingly, which means that Neo is going to go and kill probably every single person in the Matrix. Whatever. So oracles, you can see here, Oraclize, so that's one of the service providers that run oracles, are actually smart contracts themselves. And so they're listening to the outside world, they're hooked to a web API, and so you have the choice of using Oraclize so that it's a layer between Ethereum or Bitcoin, and then it communicates with the outside world, extracts that data, and sends it to your Ethereum smart contract. So this data that it gets is used as input to the function that is ran within your smart contract. I'm trying to check my notes to see if I didn't forget anything. So if you're a developer, you probably know about middleware. So think about oracles as middleware in your program. Let's move on to what exactly, how could this be an issue? Well, so it would be like way too overwhelming to the Ethereum based blockchain contracts if it dealt with all this data. So I love this image because it kind of brings like all this information that you would get on the internet, all this data would be funneled in this really narrow funnel, and then it would probably block the Ethereum network, right? Because you have all this data incoming. So the cool thing about oracles is that they're not dealing with this data in the Ethereum blockchain. So as you know, Ethereum blocks are confirmed every 7 seconds. This fluctuate obviously according to like how busy the network is. But the good part about oracles is that you can abstract that layer away from your smart contracts and have this happening off chain. So all this information that is coming in different, smart contracts that then once that information is confirmed connects to your smart contract. Moving on, we have all this diagram here. So what are like, those shortcomings of these smart contracts? So this data, right? We're always talking about decentralized apps. This data comes from a certain resource. So whether it comes from Google, Google, these big corporations are centralized entities. So you have to trust that resource. You also have to make sure that the player is sending you that information has not tampered with the data before it comes to you. You have to make sure the data is consistent, that there's transparency from where the data is coming from. So your user that is hooking up that your smart contract knows that, this data is trustworthy. They know where this data comes from. And then you have to be very, very careful. And this is known in the world of JavaScript, that you have to be careful about attacks and security, right? Because you're running a callback in your smart contract that could be calling to this other player that then can tamper with this data and send back, an attack through their code. So here you're seeing a diagram with Chainlink. And Chainlink is a very popular solution to this, and they connect with all these third-party vendors. So here you have PayPal, Visa, you have all these banks, market data, it can even connect with web APIs or backend systems and bring this all back to the blockchain. So this is really cool, right? Another thing that you need to know before I present the players in this space is that there are two types of oracles, right? So there's the software oracles, which we're mostly talking about right now. So we're talking about the APIs, the data that is coming from. And then we also have to remember that there are hardware oracles as well, because the Internet of Things, where all objects are connected to the internet, are generating this massive amount of data. I think today I went to a talk and there's about 9 billion sensors right now in the world that are producing data. So in that sense, every time, if you have an RFID on an item that is scanned through a warehouse, think about supply chain, then that data can also be, related, send back to some sort of smart contract. So then, for example, if you have a logistics shipping smart contract, they see that, that 10,000 of these items are in the warehouse, they're ready to be shipped, then boom, executes a smart contract, sends it off to whoever client has ordered these, right? So let's look at these players in the space. So we already talked about Chainlink. They have a huge community on 4chan. They're kind of, they're out there. Let's just put it that way. They have no need for off-chain API. With these nodes, you have access to this information immediately on-chain. So that's cool. BlockSense, they're actually really, right now they're connecting more to banks, to blockchain smart contracts. Oraclize is the biggest player in the game. They actually verify authenticity of the data before they're using it, and they try to avoid at all costs to use this data if it has been compromised. And of course, you have big players like IBM, Microsoft Azure. If you see here, they're really specialized in supply chain information about each product. And, so you can track all these products down. So this is really, really interesting. And, as a conclusion, and I'll leave a bunch of link below this video, but as a conclusion, you always got to think about, how do these tokens how do these tokens, how do they get data from the outside world, and where is the data coming from? Is it trustworthy? So when you research an ICO, or when you know, do your own research about if you want to implement your own smart contracts, your own coin, start thinking about that. Start thinking about where the data is coming from and how does it provide a threat to the end user, you know, because this whole point is that it's a trustless system. It's the blockchain, decentralized apps, and here we are bringing information from the outside world that can be tampered with. But there is like no one solution yet that has been found in order to protect the consumer and keep all of this as a decentralized, you know, environment. So that's something I really wanted to show you guys and provide more information. And I'll leave a couple tutorials I found for the devs out there that are interested in implementing this. But as an investor, yeah, just keep that in your wallet, in your tools, and when you're looking into ICOs. So I hope you enjoyed this video. If you did, like, subscribe, share this video, and yeah, I'll see you in the next video.